Section 12.1, Techniques for Finding Derivatives. Before beginning, there's topics that need to be reviewed on some definitions of Chapter 11 review. Tangent lines. Tangent lines are linear equations constructed from a given x of 1, y sub 1 function and slope found in a derivative of the function to acquire a derivative function x of 1 into that derivative form, find the slope needed. The tangent line. Right. A tangent line touches the function, original function, at the point x of 1, y sub 1 given, and the slope calculated using the derivative of the given function. A lot of functions, right? Now, we need to say, well, what is that equation? Tangent line. All right. It is the slope intercept form y equals m parenthesis x minus the x of 1 plus the y sub 1. That simplifies to y equals mx plus b. Follow to ensure your success. and technology visualization. Our first step in learning various ways to write and calculate derivative out, having to find the limit as h approaches 0 of f of x plus h minus f of x divided by h. Notation to replace limits. To read function f prime of x y over dx over of f of x. And cap d x of f of x. Consider function y equals a constant. It's always a straight line. y equals some value. There is no x variable slope because is no change graph. So we read left to right. Y equals 3. No matter the x value assigned, y is always 3. I'll make a chart, a t-chart, and assign values of x on the left and on the right, insert the. Now I'll graph the function. There is not a way of drawing a tangent line that can be drawn that touches the function and not go through the function. Now we could draw these, but nothing on that function. So a constant, 0. Binomial function, what is a quick way to find a derivative? As a pattern. F of x equals x to the n is found by multiplying the exponent n and decreasing the exponent on x by 1. So x to the n minus 1. Now we'll do an example. Example 1 asks, find the derivative of the function y equals x cubed minus 8x squared plus 16x plus 5 is 5. So first, announce the, the taking of a derivative for y. Y dx equals 3x to the 3 minus 1 minus 2 times 8x to the 2 minus 1 plus 16x to the 1 minus 1 plus 0. And recall that the power of 0 to any number that is not 0 is 1. Now simplify. Dy dx equals 3x squared minus 16x plus 16. Let's do another one. And in this next one, it is a conversion of a radical to an exponential. The rules are that the index of the radical is the fractional denominator of the exponent. So that we've converted it into an exponential. So we have this here, and that one is already prepared. Y equals 4x to the 1 half. Exponent is 1, and the index is 2, plus 8x to the 2 sevenths. All right. Now we take the derivative, because it is a form of a polynomial kind of. Dy dx equals 1 half times 4x to the 1 half minus 1 plus 2 sevenths times 8x to the 2 sevenths minus 1. Simplify. Half times 4 is 2. X to the negative 1 half plus 16 sevenths x to the negative 5 sevenths. Listen. Apply the rules of derivative and learn the constant rule. Not y equals some constant is going to be derivative dy d dy equals 0 is always 0. And we learn the power rule. Where we have to multiply the exponent times the x and 1 from the exponent of x. So we have y equals some x to an dx dy, dy dx, sorry about that. That wrong, didn't I? Equals n x to the n minus 1. These two rules were expanded to understanding the rewriting of a radical as a fractional exponent. Next examples apply to exponential rules that apply to utilizing the same two rules in more examples. Thank you for listening.